five minutes now from now.
Yeah, sure, sir. And very good evening to everyone. I am Radesh. This is our webinar series. I would like to welcome everyone and welcome the speaker. So, GCT Alumni Association and Vice Service Club of GCT Youth genuinely presents the wonderful webinar series, Great Conversations and Talk, bringing GCT alumni back to campus. It's my pleasure to welcome you all to the 13th edition of our webinar series, that is Introduction to Blockchain. Let me extend my warm welcome to our eminent guest speaker, Mr. Kishore Seshagiri, sir, and alumnus of GCT. I extend my genuine welcome to respected Dr. V. Presnamurthy, sir, Secretary of GCT Alumni Association, and proud alumni of GCT who are gathered here, and all the participants of our webinar. With this, my welcome note, I am going to introduce our guest speaker. He is from ECE 1999 batch of GCT. He did EPBM General Management in IIM Kolkata. He is the head of strategic initiatives and innovations at Godrej India. He is an excellent fintech leader with 20 plus years of experience in capital markets, wealth management technology and solutions. In this wonderful occasion, I would have to thank our respected principal of GCT, Dr. P. Thamai Madam, Dr. V. Presnamurthy sir, Secretary of GCT Alumni Association and the whole GCT Alumni Association, and finally student members of Vice Service Club of GCT Youth for the wonderful support to successfully presenting this series. Before entering the session, we put one request among the participants. Participants, please mute yourself during the session. If you have any questions and queries, please put it in the chat box only. Now I am handing over the session to our guest speaker, Kishore Seshagiri sir.
Thank you, Ratish. I think thank you so much for this wonderful introduction, and thank you to the GCT Alumni Association and everyone for inviting me and giving me this opportunity to present to the alumni as well as the students. Hopefully, I can do justice on the topic that I've been asked to speak. It's also interesting for me because my father used to be a professor at GCT. So it's also special that I at least get 1 hour of webinar presentation at GCT Alumni Meet, right? So thank you once again.
Please? Can I know his name, please?
KK Seshagiri.
Okay, fine. So I was blessed to listen to sir during my days. Thank you.
Oh, that's nice. So as Radish introduced me, right now I work for Broadridge India, which is financial services IT organization. We provide software to investment banks and wealth management firms, etc. Right, and for the last 5 years, I've been working on emerging tech space, including blockchain and AI and ML. And so I thought I could share some of my knowledge on blockchain to the folks who joined in. And this session is going to be fairly very basic introduction. I'm hoping to cover the history of and origins of blockchain, some of the fundamental technical concepts, technology concepts. I'm not going to do a deep dive on that. Then I will spend some time on which are the areas where blockchain is being explored or being used, and also give a brief idea about some of the education courses and certificate courses that's happening online or at various institutes that could be of benefit to the students, right? And as Rakesh mentioned, if you have any questions, please do post it in the chat. I'm hoping that I can cover the contents in around 40-45 minutes. I'll keep looking at the questions, and as and when if I get an opportunity to answer it, I will do that. Fine. So just before the just before we started, Dr. Prasanna Kumar was talking about the fact that he was quite interested in knowing about blockchain, and I guess most of us, a lot of people are very curious about blockchain, right? Because you keep hearing about blockchain a lot, and it's always often been projected as something that can be very disruptive and that can bring about significant disruptive changes to many industries, right? Now, this is something called as a Gartner hype cycle. Gartner is a consulting firm, and they typically have this model of having a hype cycle around various technology, right? And I thought I wanted to start this presentation about blockchain with having this Gartner hype cycle, just so that we have an understanding of where this technology is right now, right? So if you look at it, maybe a couple of years back, it was at the peak of its hype cycle. Everybody thought that blockchain can be very disruptive, can bring about a lot of changes, uh, etc. And if you look at now, we are beginning to see that not all the hype has materialized. It has not become real. Uh, just like any other technology, it goes through phases where it's really hyped up and people expect a lot, and then once you become very pragmatic, you realize that it can be very useful in some areas, but it also comes up with a lot of uh, limitations, and that's a good thing. So right now, I would say that we are in this phase between the trough of disillusionment and the slope of enlightenment. By that, what I mean is people now really have a better understanding of what this technology can do, and so this technology can be used for the right problems that it can solve. Right. So I just wanted this so that everybody understands that where is this technology right now, and so that we can filter the noise from the meaning of this technology. So having said that, let's spend some time on the history of blockchain. What is blockchain and how did it come about, right? Um, I'm guessing most of you are aware of what a Bitcoin is, or some of you may have probably be investing in Bitcoin or cryptocurrencies. So the origin of blockchain blockchain came into mainstream in around 2008, when a paper was published by this person or a group of people. Nobody even knows who this person is. Anonymously, they called themselves, or he or she called themselves as Satoshi. And I always wonder, maybe Satoshi is one of us. It could be one of our ex-GCT students. Who knows who Satoshi is? So if you go back in time in 2008 and 2009, there was a lot of financial crisis brought about by many of these big banks going bankrupt, like Lehman Brothers and Merrill Lynch. A lot of these big banks went bankrupt because of the credit crisis, right? And at that point, Satoshi published this paper where his view was that there should be a prevalence of money that is not managed and maintained and controlled by these banks. He believed that there should be a democratic way of having a money, and can be exchanged as a value between people without the need of these central banks or commercial banks or retail banks, because he felt that these banks actually, with all the good things that these banks give to us, they also have a lot of risk. So it was, in many ways, it's very anarchistic thought that you could have money controlled by people like you and me. We can create money, and we can create a market where this money can be used. Right. That's essentially what he wanted to do, and so he published this paper, his vision, where this could be achieved, and he called this as a Bitcoin. Right. So if you were to do some of these things, like if you were to have a digital money which can be used and can be prevalent in markets, a couple of things need to happen, right? In the sense, like, how do you ensure that? So today, if you take a bank based model which exists today, you trust the banks, you trust the central banks, right? So trust is extremely important in the way that money operates. And the second thing is, these intermediaries or these banks perform a function. One of the biggest function that they perform is that they safeguard the money, and they also ensure that what is called as a double spending problem. Meaning, let's say if I send some money to Ratish, I cannot be sending the same money to Sundra Ganesh, right? Because I don't have that money anymore. And so banks do all these functions, right? And so these are the two big challenges that needed to be solved. And this needed to be solved in a technological manner without the need for any intermediary. And so Satoshi came up with this vision on how this would work. And this is an abstract from the paper that he published. And I have basically highlighted some of the key things what this talks about, this paper talks about, right? And if you look at it, some of these and the ones that I've highlighted basically are the engineering aspects of how the system was built, right? It is essentially a peer-to-peer network between people, removing the need for a financial institution, and then he wanted to ensure that the double spending problem can be solved, and he has given some methods on how this could be solved, and and then he talked about how this can all be stored in a ledger or in a distributed database or a ledger or whatever you want to call, which is extremely transparent to people, meaning whatever transactions happens in this network, there is a way that nobody can dispute these transactions, right? So this is what he wanted to talk about, and the reason why I always have this highlighted is many people, when we talk about blockchain, we think that it's something completely new. It's a new innovation, and it's a highly complex, etc., etc. But if you start, looking at it, the fundamentals of what is blockchain, you would see that what they did was basically synthesize some of the things that already exist in our software world, right? Like a peer-to-peer network is something that already exists. Distributed computing is something that already exists. It uses a lot of encryption and cryptography and hashing, which are all things that already exist. And message broadcasting in a peer-to-peer model, or message broadcasting to a lot of people in the same network at the same time. All these functionality already exist in different ways, right? So what Satoshi did was he brought together all of this to solve this problem of digital money that can be created and used by participants in the network without the need of financial institutions. If there are any questions, please keep posting them. I will take a look at it and I will follow it. So for this, so the underlying technology that ran this Bitcoin network was called as blockchain, right? And in this session, I wanted to spend more time or talk only about blockchain, the underlying technology, and not on Bitcoin. So that's why one should understand that when somebody says blockchain, it's not just Bitcoin, right? Or any other coin. For instance, there are, I think, currently there are about 8,000 plus coins that exist in this world that run on blockchain networks. But then our focus for today's session is actually on blockchain and not on Bitcoin. So having said that, we will then talk about what blockchain is, right? I will probably take a pause for a minute. If there are any questions, I can answer. Let me check if there are any. Point of time, no. So let me move on, right? So here's the fundamental building blocks of what blockchain is, right? So as I mentioned, the key need was removal of the financial institutions or intermediaries, right? So today, all our accounts, all our money, or all our whatever investments, or if you look at an education, certificates, etc., it's all held by some trusted institutions, right? So there is a single or maybe a couple of entities, a few entities which manage all these functions and the data related to that, related to the field that they operate on, right? So when you talk about blockchain, if you had to disintermediate this, meaning if you remove these financial institutions as the intermediaries and you want to ensure that this function can still be performed, then the key thing or the key need is how does this function and the data become decentralized and distributed and not centralized anymore, right? So the first fundamental building block of a blockchain is that this is a network, and it is a decentralized network, and it is a distributed network. What I mean by that, by this, is that the data on this blockchain network is distributed amongst all the participants, so that there is no single point of failure. Um, all the transactions, all the data is held at pretty much all the nodes in the network, so it's distributed in nature. And then what do we mean by decentralized, right? So distributed is something that I think many people can understand, because distributed computing and distributed databases have existed for um, many years now, right? But decentralization is something that probably is not very prevalent. It is only in blockchain that we see this concept of decentralization. What we mean by decentralization is that typically in a network, you will have an hierarchy of functions. A lot of people do different functions, so there is an hierarchy established, be it in a technology network or be it a normal social network, right? So if you take Facebook as an example, it's a network. Ultimately, it's a network. It's a social network. But if you get into Facebook, there are different hierarchies. So Facebook finally controls your. They are the owner of the network. They can do whatever they want to with respect to the network. Unlike networks like that, where it is centralized, a decentralized network is where every participant has an equal say in what and how the network should function, right? That is what we call as a decentralization. And we will see how this is accomplished in blockchain. So the first building block of a blockchain network is it is a distributed and a decentralized network. I'll go to the second one, which is all about what we call as a mutual consensus, right? What do I mean by that, right? So let's say there's a network, right? I mean, if there's a network in your own classes or in your own groups, and you want to take a decision, there will be various ways where the decision is actually made, right? It could be maybe a majority wins decision, or it could be a round robin manner, wherein you select, you give opportunity for somebody to be a leader and they take a decision, etc. All of it, right? It's basically at the end of the day, it's like an voting, right? Now, why do we need mutual consensus in the blockchain network, right? As I mentioned, in a decentralized network, everybody should have some means of having their uh, opinions heard, which means that this distributed network, this blockchain network, this data, one has to decide how does the data, what data gets stored in blockchain, and how do we get to decide that this data is actually correct, and we all agree that this data should be in the ledger. By that I mean, what I mean is, suppose I do a transaction with Ratish. um, it cannot be I tell that I did this transaction and Ratish disagrees with that this transaction has never happened, right? So there has to be a way where this truth is established, this ground truth that this transaction happened, and that is done algorithmically and mathematically in blockchain network through this principles called mutual consensus. So the mutual consensus is a set of various algorithms. Different networks use different means to achieve this consensus mechanism. And the first one, if you've read about Bitcoin, or if you've been curious about how Bitcoin works, at blocks like other networks work, you would have come across something called proof of work, right? Now, proof of work is a consensus algorithm, where the software that running the blockchain network executes that algorithm, and then it comes to conclusion, yes, that all these nodes agree that this data is indeed something that can go into the ledger. And why do we need mutual consensus, right? So the final fundamental block is the blockchain network is immutable, meaning that once something enters into a blockchain network, or the blockchain ledger, it cannot be deleted, it cannot be modified. It is a tamper-proof database. or a tamper-proof distributed database. And the reason is exactly because you want to eliminate frauds in the financial network, right? That's what Satoshi thought. Like, I mean, if you do this transaction, you cannot then claim that this transaction never happened. And the only way you could do something like that was to make this database immutable, or it's called also append-only database. You cannot remove it, you cannot delete it, unlike any other database which has a thread functionality, right? Create, read, edit, and delete. Blockchain doesn't support that. It's only create and append. There's no edit functionality there. And hence, it is very important that this consensus happens, because you want to ensure that we don't put any data in blockchain that is erroneous, and it cannot be later on changed. Hence, these three components come together to make it very safe. And the final part of the fundamental block is that it is cryptographically secure. Now, why do we need that, right? So today, if you post anything on the internet, it is pretty much visible, right? And you may not be comfortable with that. If there is any private information that needs to be out there on the digital world, you want to ensure safeguards around it, that it is not being misused, it is not being easily available for hackers and other people with adversarial thought. And hence, blockchain uses a lot of cryptography, right? So these, if you look at it, these are the building blocks of a blockchain network. And any computer science engineer or anyone who's spent time building these fundamental networks would know that none of this actually is new. This has always been in existence. Have been used in many different applications. It is just that blockchain brings all this together to form this distributed, decentralized network. If I'm going too fast, please do give me feedback on the chat so that I can make the necessary course correction, please. So let me spend some time in talking about why is it actually called as a blockchain in the first place, right? So what is this block and what is this chain? So the reason it is called as blockchain is because of the fact how this data is actually stored in the ledger, right? So the fundamental unit of this data is a transaction. A transaction could be anything. It could be a financial transaction, or the movement of money, or movement of Bitcoin, or it could be, if you want to capture your college certificate information, for example, that data forms a transaction, right? And what the system does is it starts collecting these various transactions, successful transactions, and starts forming blocks in that. And when it starts forming these blocks, since I mentioned that it is cryptographically secure, what it does is the transaction data gets basically hashed. Hashing is a way where it's basically a unidirectional way of encoding your data, right? So uh, encoding is something that we all have been familiar, whether it is in technology or even outside, right? I mean, if you are in your, if you want to pass on some secret message to your set of friends, you would use your encoding that only you would understand, and then you would send it, right? So similarly, hashing is a way where you would use certain algorithms, and you hash the data. And what hashing ensures is that it cannot be redigested, meaning in the sense that let's take Government College of Technology, right? And if you gave the string and you hashed it, they hash, and if you use the same hashing algorithm, the output will always be the same. Now, why does blockchain use this? Because later on, if you want to prove that a transaction actually happened, and you have hashed the transaction details, and if you give the transaction details back, then you should be able to get the same hash, right? So that's one of the reasons why blockchain uses this hashing. And to be able to optimize the data that gets stored in an optimal manner, what they do is they sort of bring together all these transactions together and start forming blocks. And all they need is the hash of a previous block, right? That's all that you need. You don't need to store right from your first block to the latest block that is formed. The first block is actually called as a genesis block. So they've used some techniques and algorithms which ensure that, as long as you have the previous block's hash and your current block's data, you would be able to verify if a transaction has happened in the past, or you could basically have access to all the other blocks that exist in the network, right? So this is why it is called as a blockchain. So if you look at it from, if people familiar with data structures have taken a data structure course, you could in some ways relate this to a linked list, right? It's just basically a list of data. But the list of data within it has some interesting techniques that they have used, which we will see in the subsequent slides. So as you see, a chain is getting formed, and blocks refer to nothing but it's a collection of transactional data. That's called a block, and a chain of blocks, and hence it's called as a blockchain. And they make it very difficult for anyone to go in and make these changes in the blockchain. That's why it's very immutable, right? I think there's some questions that have come up. Let me just take a look at it. Okay, so there is one question around what are the top 5-10 fields areas which use blockchain concept. That is something that I'm going to cover in this presentation, the subsequent slides. And there is one more question around currently Bitcoin is not approved in India. How long it will take for government to approve Bitcoins? I think that's an interesting question. Again, I will touch upon some of these concepts at the end of the presentation. I hope I can talk about the third question about Bitcoin not being approved, and how do we expect, or if we do expect approval to come for Bitcoin or any other cryptocurrency. Right? So this is probably something that people who are familiar with computer science or comfortable with data structures would find it interesting. So this is something that what underlying all the blockchains typically use. There is a data structure called Merkle Trees that they use to form this blockchains, and it is very powerful data structure, and it's not only blockchain which uses Merkle Trees. There are other applications such as your if you write your code and you store it in GitHub, or maybe you use Napster, or you use any of these torrent websites, right? One of the things that you would know is that when you download, say from GitHub, some software, it is actually not bringing the data from a centralized server. It's taking data from many different nodes, and then it brings in different sequences, and then it puts it together, right? And what they did in blockchain was to use some of these concepts. They had some customization, but they did some concepts, right? So as I was saying, if you look at it, what happens is the fundamental unit of data, which is your transaction, each transaction gets hashed, right? So let's say if your L1 is actually a transaction or a group of transactions, it becomes an hash. That's what I've written as hash L1, L2, L3. And what I want to talk about in this slide is that I marked a couple of hashes in an oval, black oval, and then L2 in a red box, right? And what I wanted to indicate was, let's say L2 is a transaction that represents a transaction, a money movement that happened between Prasanna and myself, right? And then after it happened, after 1 year, I claimed that I never sent this money to Prasanna. And so what Prasanna can do is, if he presents this data of L2, and the system can easily get this hash of L2, and using the other components like hash 00 and hash 1, it will be able to come up with the latest top hash, right? And what do I mean by that is, let's say if I say that L2, let's say L2 says that I paid 100 rupees to Prasanna. And today come back and say that, actually I didn't pay 100, I only paid 50. So now the L2 transaction, if you try to modify, the hash should never be the same. And hence your top hash should differ from what currently the blockchain network shows. So it's a very easy way of showing if anybody is trying to make any fraudulent transactions or anybody is trying to make any changes to the system, right? So that's why the Merkle Trees is very interesting concept. And people who are computer science engineers and you want to get deeper into this space, do spend some time reading about Merkle Trees and some of the consensus algorithms, which is something that I'm not going to spend much time today because this is a very fundamental introductory course, introductory session I want to do. So this is, why blockchain and what is the fundamental building blocks of blockchain. Then I have spoken about underlying how these transactions are maintained within the blockchain, right? So these are some of the technical fundamentals that I wanted to spend. And then I wanted to move on to, again, if there are any questions, please do stop me and ask. So this is, so I'm getting into a territory where these are terminologies and glossary you would hear if you have been reading about blockchain, right? I mean, if you've been reading about blockchain, or if you are interested in Bitcoin, if you invested in Bitcoin, or if you've invested in any other coin, some of the taxonomy or terminology that people would use, these are the key taxonomy that they would use, right? They would say wallet, right? Now, wallet is nothing but, just as in real world, you have your credit cards and you have your money in a purse or a wallet or an handbag, which is a safekeeping of your asset. In the blockchain world, the wallet refers to a digital safe for you to manage all your assets, which could be Bitcoins or it could be anything else. And since it's in digital world, and we spoke about how we want to ensure that everything is kept safe, it uses a lot of cryptographic techniques, typically your symmetric key fundamentals, where there is a private key and a public key. And only you have the private key and only you are able to unlock the wallet, right? This wallet could be a software wallet, or it could be what they call as a cold wallet in the case that, you have a USB chip or you have any device wherein you store your Bitcoins or any other coins or any other asset, and only you have the access to that. You have the private key, right? So wallet is something, whether you work in blockchain, whether you develop blockchain applications, but if you are investing in any Bitcoins or similar coins, then this is something that you should understand, and you should ensure that you keep your private keys very, very safe and nobody gets access to your private keys, because once somebody gets access to your private keys, then your data is definitely going to be lost. I think there's one more question. Okay, there are some details about my IT experience, etc. So maybe in the end of the session, I will talk about how I got into blockchain. We spoke about transactions. We also spoke about blockchain. So the final terminology that that gets confusing for people is what they call as a mining, right? And why is it called as mining? It's interesting. So we spoke about the fact that this blockchain actually is you are going to remove an intermediary, right? Like a bank or any other intermediary who's currently responsible for validating these transactions. And this is now being validated by everybody in the network or people in the network, right? So, so the trust has to be established in a network which is inherently trustless, meaning all of us, anybody can join a blockchain network. It's a public network. Anybody can join a network, and we wouldn't even know who are the others in this network. And we have to establish that these transactions are happening, they are valid, etc. The process of validating these transactions is actually called as mining, right? And so to do this process, is validating this transaction, you actually join the network and you are running the software in your computer or any infrastructure that you have. And what you would then say is, look, I am spending some effort, spending some money, spending some computing power to validate these transactions, and I think I deserve some rewards in return, right? Because today you pay the banks. If we all do it, we would expect some rewards for us, right? This process is called as mining, right? So this comes from age-old customs where essentially when the gold rush happened in California, when people went to do this mining, how the miners were rewarded. The similar rewarding concepts have been put in place in this blockchain network, in the Bitcoin network when it was started. So they call this process as mining, right? So this mining uses this consensus algorithms like proof of work, etc., which is nothing but proof of work is very easy to understand. If you did some work, you have to give a proof that you actually work, and this is an algorithm which requires you to show that you actually done this validation, and that takes a lot of compute power from your hardware infrastructure, whatever you're running, and so that you can prove that, and then you can take that reward, right? So that is what is called as mining. But as I will talk about the evolution of blockchain, you would see that many of these things don't really matter anymore, because a lot of changes have happened in the blockchain technology. So I want to spend a couple of minutes on this term called smart contract. Again, something that if people who are working in blockchain or want to get into blockchain, this is a term that you would hear a lot. And this is probably the most powerful component in this whole blockchain world, right? A smart contract is essentially a digital program that captures any contractual obligations between two or more parties. By that, what I mean is, if I have to pay some money to Ratish, that's a contract, right? I mean, let's say I owe him 10 rupees and for something else, and he has to give me a product and I have to pay him 100 rupees. Or if I buy something from Amazon, there is a contract that is established between me, the buyer, and Amazon, or the seller who is actually selling in Amazon's marketplace. So what the smart contract does is it captures all of these things in a digital program, which is not something different from how it works today. The only difference is today, possibly every participant has their own version of our own understanding of what this contract means. Whereas a smart contract is a common representation that is captured between all parties. All parties agrees to this contract that yes, this is what we all agree. And when a certain event happens, then the contract automatically gets triggered. As an example, let's say you have a car loan, right? So that you sign a document with your loan provider. You have the agreement as to what the EMI is and what is the tenure, what is the interest, all of that. And there might be terms which says that the loan provider may take possession of your asset if you're not paying the loan, or if you missed paying for 3 months or 6 months, unless you opted for moratorium, as it happens today. So all these things now happens manually, correct? So somebody doesn't pay, then someone visits your house, or they send you an email, they send you notifications that you have not paid, all of it. But if all this can be captured in a smart contract, and if this event can be, this data can be fed into a smart contract, the outcome or the output that was agreed in the contract can automatically happen, and everything can be stored in the blockchain network so that nobody can argue. So this concept has become the most popular, most explored area in the blockchain network, where people are looking at using smart contracts to build programmable money, right? Meaning, if you define that this is, say, let's say we create a coin called GCT coin, and you give characteristics as to what this GCT coin can do. Like GCT coin is accepted only within GCT. GCT coin can buy you food in canteen, can be used in mess, can etc. etc. And you have a blockchain network, then the characteristics of this GCT coin can be programmed, and nobody has to do anything manually. Everything will be done by this smart contract itself as to when this coin will be accepted, when this coin will not be accepted. All of that could be programmed, and all can be agreed by the various parties. So this has become very powerful. And now what is also happening is many people are exploring if we can take the smart contract away from blockchain and this can be used in other databases. And one of the companies which is doing is AWS or Amazon's cloud arm. They come up with a database called QLDB, Quantum Ledger Database, which carries a lot of blockchain's characteristics, that is immutable, tamper-proof, all of that is there. And they can run smart contracts on top of QLDB. The only thing that it doesn't have is it's not decentralized. Amazon owns it, but a lot of other power of blockchain can be run on QLDB. I will again look at the questions and I'm in trouble. Okay, there are some questions around big tech firms, right? Yeah, I think I'll just answer this question before I move again to the presentation. So yes, all the big companies are involved in blockchain. IBM has their own blockchain platform called IBM Managed Blockchain, which runs on an open source Linux blockchain platform called Hyperledger. Google provides infrastructure to run blockchain. Microsoft, same manner. Azure provides infrastructure to run blockchain frameworks. AWS, Amazon has their own version of Hyperledger blockchain, and they also provide infrastructure for you to run any other blockchain. So all the top companies have invested in blockchain, and right now their focus largely seems to be providing the infrastructure to run blockchain networks, but some of them are investing in it. Facebook is slightly more interesting. Facebook actually they are creating what we call as a coin called Libra. They announced a work where they want to create a coin called Libra, which is a representation of various used currencies. Like, it can be representing an US dollar, it can be representing an Indian rupee, and they will have a digital representation of all of this called Libra. But that has not gotten approval from regulators yet. But Facebook is taking a different approach. They're not focused just on underlying blockchain technology, but they're a lot more focused on the digital coin, or similar to Bitcoin, but a regulated digital coin, whether Facebook can create it. That's their focus. There's one question about blockchain network is impossible to hack. Yeah, conceptually, theoretically, it is impossible to hack. But we have seen that there have been cases where some of these blockchain networks have been hacked, and so that is something that people are working towards it. Yes, I noticed the screen share has stopped. Let me fix it. I'm just going to stop sharing and again start sharing. Yeah, I think the screen has come back now, right? Yeah, okay. So now, before we jump into one of the questions that people ask, which industry is using this, let's just summarize what is the benefits of this technology, right? And then we will understand why people are exploring using blockchain. So the biggest advantage of blockchain is it's a single source of truth. Since it's everybody in the network has access to the same data, every node or every participant in the network has a copy of the data. It establishes a single source of truth. Nobody can dispute that this transaction did not happen or this data doesn't exist. So it provides transparency to the participants in the network. The second feature, the second benefit is this immutability that we talked about, that nobody can make changes. It's tamper-proof. And so what it establishes is it's a data lineage and auditability, right? So this is an example where now educational institutes are looking at, having your educational certificates and qualifications in blockchain. So that you can establish a lineage of that certificate. Nobody can make changes, or even property registry, right? If you buy a house, you would know, if you look at things like an encumbrance certificate, you would know the track of how this has changed, like right from when the land was registered, who owned it, who did they sell to, and that can, today there can be a lot of manipulation that can happen, resulting in fraud. But if you were to digitize it and capture it natively in blockchain, the theory is, because it's immutable, it cannot be, it can reduce this fraud, right? The third benefit is decentralization and distributed nature means there is no single point of failure. So let's take an example of, say, a bank like S Bank, right, in India, where now they're having trouble, but then the government is helping them out. But let's say you saved all your money in XYZ Bank, and XYZ Bank went bankrupt. Then you go through a lot of hardships to get your money back. But if you have a blockchain-based decentralized way of supporting that, then the concept of the theory is that you will reduce the single point of failure risk. So these are the benefits, right? So building on these benefits, which are the areas where people are looking to use blockchain, right? So as I mentioned, one of the most popular use cases that many governments, including Tamil Nadu government or many states in India, as well as foreign countries, are trialing out. None of them are in production yet. The piloting is this concept of registering your property or any asset in the blockchain, right? And so that that it can establish a way where no change can happen to that, and everybody is having access to that in a transparent manner, and frauds can be eliminated. So that is one area where a lot of pilots are being done. The one that is more successful or at least blockchain solutions are in production. So one of the things that I do want to mention is, of at least in all the technology that I am aware of, probably the failure rate of blockchain is the highest. What I mean by it is, like 6-7 years back, a lot of people started working on blockchain, and today at least 90% of all those projects have failed. There are very, very few projects which are actually yielded benefits, and people are making some revenue out of it. One area where blockchain has been successful is this supply chain transparency, right? So today, if you like, let's take the case of Amazon, for example. They sell a lot of goods, and there's a lot of behind the scenes things that happen. The supply chain is extremely strong for somebody like Amazon to deliver on the time that they deliver. They bring together so many players behind the scenes, and there is so much of connectedness that happen between all these players, right? So companies like IBM, Walmart, they've taken some specific areas where they've applied blockchain, where they've been successfully able to trace the movement of goods, or at what state is the supply chain is out there, or what they call the provenance of an asset has been established using blockchain. Again, here blockchain is being just used as a data reporting tool, right? It's not necessarily bringing any disruption to the way the supply chain actually works. But then you are getting real-time view into the supply chain, which today happens through disparate ERP systems and other systems, supply chain management systems. Blockchain is being used to show a more real-time view, and there has been some success in that. On building on top of that is the contracts that people get into the supply chain, right? I mean, and also the trade finance, that because most of the supply is all global. It happens between some supplier in, say, Canada and somebody in India, somebody in Australia, etc., etc. So all these contracts, IBM, Walmart, a lot of people have digitized this using smart contracts, and they are seeing cost reduction and risk reduction in this. So that is one area where blockchain has been applied, is being used in production. Again, very, very small usage compared to the big market size of the supply chain industry, but some success has been seen. Another area where blockchain has been successful is the cross-border payments and forex markets. So let's say you, I think Pradeep is in Connecticut now, right? And if he wants to send money to somebody in US, he would go through, say, any of the money transfer firms, and he sends US dollars, which today it takes around 6 intermediaries. There's a couple of banks in US who the bank in which he has his account, then that bank sends to the central bank, then they send it to India, and India, not many banks have correspondent banking. So, and then finally it reaches his, the recipient's bank. And this process, people charge a lot of money for this conversion of US dollars to Indian rupees. What people are doing using blockchain is that they are representing the US dollars and Indian rupee in different digital asset manner. Or these are what is called as coins, right? And this is where Facebook wants to get involved. Facebook wants to have this coin called Libra, or a collection of coins for Libra. And what would then happen is, once you are in this Facebook network, the US dollar gets converted into a Libra coin. The network transfers Libra coin from one destination to another destination. The cost of this transfer is reduced because it all happens in Facebook's network. And then finally, the Libra coin is transferred into an Indian coin. You can convert that into an Indian rupee, or Indian rupee. So the cost is reduced a lot. And then because there are other ways of doing this, the theory is that financial inclusion is more possible. So this is, again, payments is another space where a lot of people are exploring the use of blockchain. And in subsequent slides, we will also talk about what governments are doing, because they don't want too many private players like Facebook and others getting involved in this. So how is government approaching this? And that could possibly answer the question that people ask about whether Indian government will agree to Bitcoin, right? In Broadridge, we have been successful in using blockchain for corporate voting. So similar to our normal public voting, if you are investing in stock market, you would know that companies have AGMs, right, where they elect directors, they elect chairman, CEO, etc., etc. So Broadridge provides services for running this corporate governance process and voting. So we've used blockchain to make this a very secure means of voting, and we can give real-time results and transparency on how this voting has happened. And we've also used blockchain in trading and settlement. What I mean by that is, if you buy a stock, you go to, say, an NSE or a New York Stock Exchange or a Bombay Stock Exchange, you can buy it, but there are certain transactions that happen between people outside of these exchanges, right? So that has a lot of risk. And what we have done is, using blockchain, we have reduced the risk and reduced the cost. So these are some of the areas where blockchain is being used. But one of the most interesting use cases, which is probably the one where I believe blockchain will add a lot of value, but today it is not happening, is this whole concept of decentralized identity. So if you log into internet today, you would see that a lot of these websites allow you access through Google, Twitter, Facebook, LinkedIn, etc., etc., right? So your identity is registered with one of these big tech firms, and that identity gets used by other websites, right? So the problem, if you've seen, is how do these tech giants misuse your data, or are they making money of selling this data, right? Your identity is probably getting sold. So there are many companies trying to use this blockchain where you have the power to control how your identity is being used, and that's called decentralized identity. No success has happened yet, but this is probably the most significant disruptive use case in my mind. And we'll have to see if it gets successful, or if this tech companies allow this to be successful in the first place. Right? So that is some of the use cases. I hope it answers the question that somebody had asked as to where this blockchain is being used. Right. So these are real world problems, and these are where this is where blockchain is being considered, and some of them have been successful. And as I mentioned, the failure rate is very high, and I have an opinion on why it is failing a lot and what we can do about how it can be more meaningfully used. So I don't know how much. Yeah, so we are running out of time. So I'll probably quickly go on. What has happened is, this is a state of blockchain technology. So the blockchain itself was inspired by things like Napster and torrents and all of that. And then we saw this Bitcoin, and Bitcoin did just movement of Bitcoins. Then the most powerful or the most popular network, blockchain network, one of the networks is called Ethereum, which allowed people to write smart contracts on the blockchain network, and where you can develop a lot of functionality around that, right? And then what has also happened is, like, companies like Broadridge, IBM, Facebook, Walmart, Amazon, etc. We are all enterprise companies, so we think that we can use blockchain, but we will not open it out to the complete public, right? We still want to safeguard, because we are dealing with highly secured private data. And so what has happened is, people have taken blockchain and built private permission blockchains called distributed ledger networks. And there are certain companies, I've mentioned that. I can probably send the slides to people because we are running short of time, right? Having said all of this, right, if you ask me what is happening in the world today, where people talk about blockchain, I think this Dilbert cartoon captures that. So everybody would come and say, okay, let's just build blockchain because blockchain is the biggest hype, right? I mean, just like how data science was, and AI and machine learning continues to be, uh, there'll be a lot of this talk about, okay, let's build blockchain. But most of the times, we have no clue about how we want to use blockchain, or how blockchain can solve a problem. And that is the biggest reason why we haven't seen too much success in blockchain, because in many ways, blockchain is still a technology which is looking for the right problem to solve, right? And this is where I would think that, where you would consider using a blockchain. I'm just trying to simplify it and codifying it as to when you should consider a blockchain. Unless there is a network where a lot of participants are involved, you should never consider blockchain, right? I mean, if it's just two people having a problem, you should never do blockchain. You could use just a database to solve that problem. If there is a network, a lot of interactions happen between these networks. So supply chain is a classic example. There are just so many participants, so many data getting interacted, so many contracts that get exchanged between all these people. And there are a lot of errors, there are manual processes that happen. And there are people who are intermediaries who are actually solving this and making money out of it, right? That is exactly the place where blockchain could potentially be used. Otherwise, stay away from blockchain. Blockchain is an overhead. It doesn't help you unless you're solving a network problem. And if there is a need for complete privacy and segregation of the data, then you should move away from public blockchains and use private permission blockchains or distributed ledger network. So this is like, a simple a cheat sheet for you to understand when would you use blockchain, right? And finally, why is blockchain failing? As I mentioned, like 90% of the blockchain has problem because the technology is still, a lot of limitations exist in the technology. It's not very fast. It doesn't integrate with other technology. It doesn't, and there are so many different blockchains. As I mentioned, not all blockchains talk to each other. There's still some questions around, how secure it is. People have shown that it is can be hacked. So this technology problems means that blockchain is not yet mature, not yet ready for large-scale production deployments. But technology problems can always be solved. There are smart engineers around the world, many of them GCTians, so they are solving many of these problems. But then the non-technology problems is a big hindrance, right? Because the whole world, capitalism world runs with somebody making money out of the business, right? Somebody has an idea, they want to get into this to be economically profitable. Now, if you tell them that, let's all come together for the greater good of the world and let's all share the benefits and profits, it is socially and culturally something that probably we are not yet ready for that. And how do we governance model around it? Can we all come together, coexist, and come to a consensus? Is something that theoretically and conceptually everybody agrees, but when you put it in real world, there's a lot of challenges. So the economics around blockchain networks are not very strong. So these are the reasons why 95% of your blockchain solutions actually fail. So one question that the last question that I want to take was that there was a question around Bitcoin, whether Bitcoin will be approved by Indian government, right? And what I think would happen is most governments would not be comfortable with things like Bitcoin or things like privately issued coins because they don't have control on that. The government still want to control the economic policy and the monetary policy. So what many governments are trialing is what they call as a central bank digital currency. So even India, RBI, and China has been the first country to start looking at how they can issue Bitcoin-like coins, but issued by the government, right? So this is not truly decentralized. There is government behind it, but they want to use the benefits of the underlying technology. And I think in 5-6 years, you would start seeing the central bank digital currency becoming more popular. And one of the other reasons why a lot of countries, especially in Europe and or China, for example, are wanting to take leadership in this, is that today in your global economy, there is a lot of dependence on US dollars. This potentially offers them an opportunity to, change that dynamic. So this is one thing that I would say that, my guess is Bitcoins would not be very acceptable for governments, but governments would start exploring CBDs. So that's pretty much I had. What I wanted to say was, what I see will happen is a lot of the benefits of blockchain would be applied. Whether it will be blockchain or not, I don't know. What I mean by that is concepts like, tamper-proof immutability, concepts like smart contracts, concepts like, consensus building, we will start seeing in many of these software applications, but it may not actually need a distributed decentralized ledger. So with that, I will finish. I think there was a question about how I got into blockchain. I'm not sure I have time to answer that. If people reach out to me separately, I can speak about that. So Satish and team, is this? I think we are done with the time. So hopefully this was helpful.
Yes, sir. So we have Sundar Ganesh to give the closing credits, but participant can just stay on, post the credits for post discussion. We'll be having a few more minutes with the speaker. So Sundar Ganesh, over to you for closing credits.
Yeah, maybe before that, there was one question that probably I can answer. Like, can we see blockchain being implemented soon in unorganized labor markets and municipal agriculture markets? Again, yes, it can be used, but as I mentioned, what is the real problem that we are trying to solve on that, right? Because right now, if you see, unless something directly originates in the blockchain, the power of blockchain is not really very high. If what's happening in your labor markets and agriculture markets, blockchain is only going to store the data and represent what is happening there. But if the data that is actually being fed into the blockchain is itself incorrect, then there is a problem. But having said that, let's assume that with all these new rules, new regulations that government has announced, right, the farmer bill, if they codify it and they put that in a contract as to, okay, farmers and all the legal language is written and captured in a smart contract, then yes, you have a way where uh, many of these, the private companies cannot manipulate the farmers. And because you've agreed to a contract, it is all stored in a smart contract. You have transparency to that. But then again, I'm just thinking aloud. I don't think I have answered that question properly, but that's my thought.
Thank you, sir. So Sundar Ganesh, yeah, you can go with the closing credits.
Yes, sir. First of all, I need to thank the speaker of the today's session, Mr. Kishore Seshagiri, sir, who spent his valuable time with us. Thank you, sir.
Thank you, guys. Thank you for, again, the opportunity.
And then I need to thank our honorable principal, Dr. P. Thamare, madam, who continuously supporting us to run this session. And also I need to thank the secretary of the GCT Alumni Association, Dr. V. Prasanamurthy, sir. And then I need to thank the Vice Club of GCT Youth as well as GCT Alumni Association, who running this session successfully. And finally, I need to thank all the participants who all are gathered here. Hope that it was a wonderful session for you. Thank you all.
Thank you, Sundar Ganesh. So with that, I'm gonna stop the recording and stop the live stream. Maybe I will open this up for the participants. So participant who want to ask any questions to sir, you can just raise your hands or you can unmute yourself. So the floor is open for you.